I know he is. What you guys have brought to the Glowbusters is what we kind of lost when we lost Bob. The more technical, I mean, you guys are sharp. Let's just, I'm not tooting my own horn too much, but yeah, you guys just blow me out of the water when it comes to, just, you guys are on it. It's awesome to have you guys on the team. And I know Bob's happy. I know he is. Just having you guys here, and we've lost some people and stuff like that, but the replacements are just phenomenal. So just keep doing what you guys are doing. I mean, yeah, it's like every episode is like another nail in the globe every time.
Hell yeah, man. Fun Sundays, right?
Yeah.
That's awesome, man. Thank you for the kind words.
Thank you.
Yeah, every episode a banger. That's what we strive for here. You guys set the bar pretty high. When I was a young lad coming up in the flat Earth community, absorbing the info. So I'm glad to continue on that legacy and build upon it.
E-Root presentations were like, okay, I'm going to present something where I'm going to be so visually overwhelming and persuasive in my argument that you'll have absolutely no position except mine when it's done. Are we clear? Okay, sit down. 3.5 hours. Here we go. Dude. That's kind of how both Alan and I started doing presentations, I think, way back when, until we learned how to trim them down to be more digestible, I think.
When I started doing prezzies, I call it the Iru Landucci model. Because every time that dude on Glowbusters, he would be like, oh yeah, I got a quick prezzy I can whip up to show you the references on that. He would pull up a full 100-point PowerPoint and just rail through everything. Like, it was so concise, and it just, he always had it available. So I was like, we need to bring that. That needs to be the standard for everyone moving forward. So yeah, that's what we try to facilitate.
Where do I hang out with friends who can do that on command? Where's the group of people where I can just pick a person and anyone can do that? Oh, nice. That's where I want to hang out.
What's funny you mentioned that. There is such a place, Ether Cosmology Discord. You go to discord.gg/ethercosmology with an A for starting with Ether. You can join the Discord there. And I think a link will be provided in the chat as well. But yeah, with that.
Yeah, just jump in. You don't have to talk. Just jump in and listen to some of the conversations that people in these chats are having.
Dude, just read our text chat. It's nuts.
Yeah, this is high level thinking going on here. It's awesome. It really is.
All right, so tonight, Shane has a little prezzy for us on an ancient Greek man. Some of you may know him as Eratosthenes. We're told he did a certain something measuring sticks and shadows from the sun on a specific day, and from that he was able to deduce almost the exact dimensions of the Earth. He was off by a little bit, Shane. He was a hair off. But
what's your stadia conversion? It turns out, but
Well, what's a ratio conversion between friends? If you know what I'm saying. If you're using the same coordinate system, we can plus or minus it as much as we want. So history is cool like that. So yeah, we're going to go over that and break it down. So Shane, whenever you're ready, good sir.
Sweet. Yeah, so this is a good one. I think I saw some posts around Facebook that were like, oh, sun angles, like the bane of all flat Earth, like everyone kills it. I mean, to be fair, it was a huge problem, but it was also one of the first things that we wanted to address, right? So that's why we all use the same sort of model to demonstrate these stellar phenomenon. But if we look at just Eratosthenes and we look at, say, sun angles, and we say the biggest problem of flat Earth is probably the sun. That's what I would say. Right, sun angles get misinterpreted on a Gleason's map or an azimuthal equidistant projection. Sun angles get misinterpreted over the strength of the whole flat Earth, assuming that everyone can see everything in the sky at all time, right? Also not true. So to apply that to the day, you want some different sort of differential interpreting, I would call it. And then we can reapply what is a well-known measurement and which is a repeatable measurement about, when you get a circumference of something, it's trying to figure out, well, the circumference of what, right? What are we actually measuring? So we'll go into it briefly here. We have, the basic terms we'll be throwing around of a circle, right? This is all the parts of a circle. Surprisingly, it's the same part when they try to use, the circumference of a sphere. There's no differentiation. But if we have the circumference, it's the distance around the outside edge of a circle, right? We have the diameter, the distance across the circle that goes through the center. And then we have the radius, which is the distance halfway across the circle, equal to half the diameter, right? So we're going to be using these terms. It's always good to define the terms that you're going to use. So the formulas for these, right? The only difference between actually a circle and a sphere is area, but we'll get to that later. For a circle, it's pi r squared is the area. The circumference comes out to 2 pi r. Diameter equals 2r, right? So we're only really going to be using this one, but those are the mathematical formulas that we're going to be using. So Eratosthenes, the mystic Greek, who was, the smartest Greek alive, invented all these tools well before anyone needed them, is very well researched in his, historical validity. I'm being hyperbolic and superfluous, of course. There's no actual evidence of this ever existing. The only reference is another story. So in one story, they reference this story, and then today they tell us that reference to that story is evidence that first story was real. But we'll get into that a little bit later. The basic premise of what Eratosthenes sort of measured, right, was huge assumptions baked upon a prescribing of a circle, right? So his big mathematical genius was, hey, we're going to imagine that this is the circle of the Earth is 360 degrees. We're going to divide it into little sections. We're going to measure the difference in angles between a well in Syene at the tropic on solstice, meaning the sun is directly over you, and Alexandria with the sun is not directly over you, but there's a difference to the 90. We're going to measure the difference between these two. Comes out to 7.2. What his mathematical genius move was saying, hey, now I'm going to divide this by 360. So he's effectively making this, the circle of the Earth, and he's saying relationship. I'm going to make a ratio between the distance on the Earth, which he happened to already know at this point. Don't worry about how he knew. Was the distance between these two is exactly 800 kilometers, and that ratio has to be the same between this ratio of the circle. So they're going to use a proportion based on a circle to estimate one arc length of that circle, to then estimate the whole circumference. So that's what he's doing mathematically, and he's the math is 360 divided by 7.2 times this quote previously known distance, 800 kilometers, gives us the circumference of the whole circle, 40,000 kilometers. So that's how he quote did it. And of course, the main assumption is parallel sun rays, which we have an equivalence for if you want to do for a local sun with the proper angles and proper observations. But let's first go into how this proves the globe and how it's a problem for flat Earth, because every glober will bring it up under that context, right? So this is how they supposedly did it, right? A stick in a shadow. I think this is called a notum. I forget. It's like a Greek tool measuring shadow angles specifically. They did this all the time. For the other presentation, we use a presentation by our boy here, Decimal Z, who used to be Dr. Zach. I think I saw Karen B throw a video of his up on this exact topic on her stream last week, which definitely gave me the inspiration to do this because he put a really good video together. Instead of watching that video, though, we're just going to go through it real quick because it's super long. I'm just going to go through some of his slides here, and we're going to go with his main positions and what he was arguing. And his presentation was called, the biggest problems for flat Earth. And it was, in fact, about sun angles, right? And then he went through Eratosthenes as well. So his argument was that understanding how sun angles work in reality is how they actually built this whole globe model and globe Earth map. And his second point was that if we understood that, we could do the same for a flat Earth map. That was the intro to his presentation. And he went in with, trying to use the sun. And when you take sticks and shadows to measure the sun, or if you observe the sun over a period of time, you'll notice it does these semicircle arcs in the sky. Depends on your latitude, actually, where you'll see it, but that is, in fact, what it does, right? It looks like this, changes throughout the year. If you were on a flat plane and the sun would do this arc sort of above you in 1 month, and as it moves on its precession from tropic to tropic, it gets closer to you and closer to you. And in the north, it does, in fact, get higher and higher, and then gets lower and lower as it goes out. That is the actual path of the sun. And this is the basis for not only Eratosthenes' measurements, right, but also when he was assuming parallel sun rays, this is how they, quote, discovered the tropics and the tilt of the ecliptic. But we'll get into that a little bit later. Real quick, here's how the equivalence principle works, how the sun angles work on a flat plane compared to how they would work on a globe. And if you just take this flat plane and stick it as tangents on this globe all around it, you actually get all the correct measurements of what the sun does, right? So this is, in fact, how the model gets built later on, right? Which we're actually going to look at next. It's just this observation built out over the globe. They took a whole bunch of a collection of alt-as observations of the sky, right? That's altitude and what do you call it? Just alt-as grid, right? Your basic alt-as, taking your horizon, and you get your alt-as grid over you for each observer. That's the only basis for creating this model. They just used multiple observations, stitched it together, created the celestial sphere, extrapolated the globe into GP and coordinates from there. But let's take a quick look at how this would be displayed in a model that would account for all of these different angles, right?
A little low.
Yeah, I think I recorded it low.
Okay.
Eyes and set and do a perfect little arc. Also, you might have to turn stream volume up. You'd see it, arc across the sky in a semicircle like that. And if you go south of the equator, you would see it go the counter rotation, right? So you'd see. I'm just mimicking the same semicircles in the sky right now. So in the south, it rises south of east and sets south of west. In the north, rises north of east and sets north of west. Inside the little bubble, it would look a lot like this, right? See the sun do one of these, rising and setting, right? And if you move your location, you can see how the arc of the sun moves with you like this. This is the whole basis of the globe model, is these angles to the sun, right? You can see as you move, the ecliptic sort of tilts with you, and that's the path of the sun, right? You can tell much better on this perspective how it's tilting and doing little semicircles in the sky, essentially just like this, rising and setting depending on your latitude, right? That's what it is, a latitude-dependent celestial arc, right? And if you were to try to use a collection of these latitude-dependent celestial arcs to create a map, you would probably create the globe, right? So,
and if you're having an issue visualizing that, just think the further north you go, the more it points up towards Polaris. If you see that representation there. Yeah, I like that thing.
Right? I think this is a really good one.
Yeah.
I think I took it from a Glober, and they get mad every time I use it because they're like, "No, that's a globe meme," and I'm like, "You guys don't understand memes, so I'll take that from you before you hurt yourself. Give that over to me."
Yeah,
That's
that's
a
a
really
cool
good
little
one.
tool right there.
Right, because you can see if you only made these observations, how you could stitch them together to create this and be like, "What? I did good, right? Like I did it. I solved it." It's like, well, no, and that's what I wanted to go through, right? It's what his position here, Dr. Zach, our boy, says. If you only wanted to know what you live on, you only had a measuring tape, sticks and shadows, and your brain, right? And he takes us through the process of how you could create it based on angles to the stars, and in the process, or angles to the sun in this case. And through that process, he goes through and finds and points out the biggest problems for flat Earth, which namely is this bad boy right here, the sun. It does not behave like a point light source or like a lamp. It really doesn't behave like any other thing in the sky. It's kind of its own thing. So when we equate things to it, like say a lamp, and we expect it to act like a lamp, it's kind of weird. It doesn't actually respond to it, right? When you start to triangulate it like this is showing, you get a height 38, 70 miles. That would vary depending on your position. If you get more people to make the same trigonometric assessment, you start getting different heights. Everybody in flat Earth knows this.
2880 when I did it.
Right? Everybody in flat Earth knows this. This is a fact, which is why, they try to trap the newer flat earthers. Globers come in and they're like, "Hey, how high do you think the sun is? Give me your sun distance." So they can immediately do one of these and say it's different and show how dumb that is, right? But who hasn't been trapped by that? Someone raise your hand.
It's a classic.
I gave a distance when I first came in, dude.
It's a classic, like, 3959 or whatever.
Yep. That's why everybody knows that that's a no-no, right? You can't do that because it can't really be triangulated, because when this method doesn't work for an apparent or refracted object, depending on how you're going to look at it. And we'll go through another presentation through where actually Dr. Zach mimics this whole thing, sets up his table and takes a circumference measurement of his totally flat rectangular table and does it so well down to the decimal point over with 4 different observations. And we're definitely going to watch a little bit of that. But in this case, we're just saying, hey, if you just use the tools that we had before and you start making calculations using basic trig, you'll get differing angles for the sun, assuming a flat Earth. And that's why they get this little diagram, which I also thought was great from Dr. Zach. So he's putting together, Eratosthenes' genius over here is dividing it into a circle, dividing that into 15-degree sections, and then saying that the angle for each section is 15 degrees. It's the same no matter where you are in the circle. Therefore, the distance between these sections is equal. And then he comes up with, 1,037 kilometers per 15 degrees, right? Now that's how far it travels. So he sketches that out on a triangle. You can also confirm these using basic trig. That's what this overlaying distances are, right? 5362 for this triangle, 4789 for this triangle. It's just a mathematical sort of pictorially represented trigonometric function of this distance and expression over here. Now, where did he get this amount? Well, the easiest way to think about it is an arc length. You would get this by already knowing the radius of this. And I can't think of any other way to do it, because the other methods you would need to know the distance already between these two, which if you're trying to figure it, you wouldn't know, right? We're only trying to use the sun and the measuring tape that we already knew, so we wouldn't know that distance. So the only way it could possibly know is by knowing it already. So that we'll go through that later, but just know this is an arc length segment of this entire circle, and that's what we were talking about earlier with the circumference measurement and how he was doing it. I also thought he represented the problem this poses very well, right? He put this slide up. And this is how you would observe the sun angle at different latitudes, right? They only converge by latitude. You get a host of differing positions for the sun if you do it correctly. And then he says you only solve this problem by starting to bend the Earth downward. And he's doing the progression here of the more you bend the Earth downward, the more the angles, quote, line up. Now, if you know about it, this is really just a mathematical cop-out, right? This doesn't actually solve anything. All that does is move it. Oh, man, that's supposed to move? My gift didn't work. That's all right. So by pushing this to concavity and pushing these angles, or this distance to effectively infinity, that doesn't actually solve anything. That's a cop-out. You've made the angles, quote, parallel, but not parallel because they ultimately converge at a point, but parallel enough for you to use them in all your calculations to count them as near parallel. So a nice mathematical trick that solves one part of the problem, right? And he agrees that the only solution, if you're going to use geometry, is to bend the Earth downward, because this is the inherent problem that's presented there, right? You got the flat Earth reality, which is what we see and observe via crepuscular rays all the time and with a point source. We have diverging rays from an observer-dependent point source casting shadows on a flat surface. And we have these sticks over here, which some corresponding angles. Or you have the globalist space magic paradigm, when you bend the whole Earth that's never been seen in different ways. Then you assume that all light is parallel, even though no one's ever seen a parallel light ray in all of existence. And then you get the same mathematical angles, and you can say that you solve the problem equally, right? These two observations are mathematically equal. Any questions so far? Any people in Discord?
No, you're crushing.
Yeah, I remember having that conversation with my mom. I was like, they told us today at school that all the sun's light rays are parallel. They all come down. I was trying to say parallel. I was young, and I was like, that doesn't make sense. I don't see them like that. Like when they come through the clouds, they're always going out at different angles. And we didn't have Google back then either, so it was
how did your mom reconcile that one for you?
yeah, there were so many things that she was just like, see, eventually, as the question started getting harder, it became, I don't know. A lot of it was we'll have to go look it up, and we would go to the library and get a book on it, and I'd read about it. But this one I could never take what the book said and put it with what I saw with my own eyes. It never made sense. I couldn't, work that out. It doesn't make sense.
It's hard to accept something that no one's ever seen and just know that that's real. Because
gaslight yourself.
Yeah. Even as a child, it was like, no, that doesn't make sense. No.
All right. Well, what if we need it to be the case for our math to work in our whole model? Are you going to think that you see it now?
I could not stand physics and science.
Do you think you maybe see that line straightening out there?
Yeah, great. That's a crazy thing. And they get us with this all the time. And remember that this is one of the key assumptions tying this entire observation and all the math together, right? Is that wild assumption of parallel light rays that nobody's ever seen. So the other thing that Dr. Zach's model brought up, and I think that we all know is a problem for flat Earth, is that the elevation angles will never intersect like you see in this diagram, right? That's why we need our observer-dependent spherical grid, their azimuthal grid of observability, or azimuthal grid of vision, or whatever you want to call it. Atmospheric dome, there's all sorts of terms for the same principle of the limit of vision applied over the observer, which puts the sun in an apparent position for each observer. That's the one and only way that sun angles work on flat Earth, is that it's an apparent position for all of us, and that since no one can see all of the sky, you have a limit to your vision. Those are two base assumptions that I think we're very founded in making.
And real quick to add on to what you said there, the only way it works on a flat Earth, it's the only way it works on any model. They're apparent in both models. There's no, we're not going to perceive it differently on a globe. Like we only see it the one way. So it's not like it's like there's a special globe explanation for it. This is the explanation is everything is apparent. 3D space is Euclidean. How we perceive 3D space is hyperbolic. It's different. There's a deviation from the two. And that means that everything is apparent, especially when you come to things in the sky, like the celestial bodies. Those are, they arc across our dome of vision, right? Our own personal firmament.
The celestial arc.
It's an optical phenomenon. Yeah, your celestial arc of vision. Oh, you want to use the graticule?
Beautiful.
You mean the thing that's mapped to your celestial arc of vision? Okay.
Right.
But yeah, so just to like reiterate real quick before we move on, because this is like extremely important to this concept. In both models, the positions of the bodies is always apparent. The reason they needed to be Euclidean and parallel light rays and all these things is so that they could apply what Shane's showing right now, where like convergence points for everything when they extend it out far enough. And then they could say, look, here's where the physical object is, even though we're always, no matter what, if you press us, we will tell you, well, yeah, it's apparent. Like we're just, the sun's 8 minutes behind us, the moon's refracted, yada, yada, the stars, they're not in their positions. All of the math that they started with, the baseline for all of these, started out with plane trigonometry with triangles that would add up to 180 degrees. Well, you can only get that under certain assumptions if you were like, hey, this star is right here, it's supposed to be here, we do this trigonometry, it should be here, we look up, it's slightly off, what do we do? Is the Earth a ball or is the sky a ball? Like, are we perceiving through a ball? Like, it's all the same situation. They just chose to tell us that the ground curving is why the stars aren't in their idealized Euclidean position. But that position doesn't exist. That's not what we perceive, and it's always apparent. It's always in the celestial arc.
Right, yeah, that's one thing that Eric Dollard had said, a long time ago. That's one of the things that I've been like racking my brain on. That the sun is not, you're not seeing light that's 8 minutes old. It's instantaneous. It's interacting with the atmosphere here. He said the same thing with the stars. That light, it's not traveling all of these long distances.
No, it happened 8 minutes ago. Zach, shut up. Yeah. You don't know what you're talking about.
He says it's instant. He even said it's not a burning ball of gas. And this was an educated, as highly educated as you can get in that field, sent to study using one of the big giant telescopes. He said, I looked right through the sun. There is no center of the sun. It's it's pretty much a flat disk.
Nuts.
Interacting with the atmosphere.
Pretty crazy.
Yeah. So,
yep.
So who knows what it is?
Do these angles
but they do
are
like
the same,
to put you in that bubble. They like to put you in the bubble of you have to make it a physical object and explain it. You can't let them do that.
We know exactly what it is. How come you don't? You didn't learn your guesswork down to astronomy? A gaseous giant ball built of galactic accretion that's attracting nothing from nothing, a mass using an instantaneous action across a distance with no explanation, but also using galactic accretion to somehow form itself into a burning ball of gas, the burning hydrogen, iron, helium, oxygen, all the way down to the heaviest element until it explodes into itself to create more of you everywhere. You don't know all that, dude? You don't know the actual basis of everything?
to create more of you everywhere.
Yeah, everyone is Stardust. Dude. You didn't know?
It is quite a cosmology from
Like,
nothing.
dude, if I'm supposed to replace that, you can just take a seat, right? Like, come on, that's
That
retarded.
might have been better than Mr. Garrison's explanation of how we got here. I love that, Shane. That was a good one. That one's got to get clipped right there.
So, dude, so the problem they were trying to solve, they solved with a mathematical cop out, right? In my view, these positions are still mathematically equivalent. All you need is a transform, right? This is the same observation angle of the sun, where if you push it to effective infinity, they look, oh, all the angles match. This is how they get their circumference. This is how the assumption carries with the circle, of which they can use an arc length, right? So I love this animation. I forget from whom I stole it, but thank you very much. I know that it was awesome. This one too shows the exact sun height, right? 6,210 miles or 10,000 meters. That's the actual maximum distance that anyone would see it, right? That's why we use that all the time. And then here's what the angles would look like stretched out each observer from latitude. So literally from zero from the equator to the North Pole, here's what the angle would be, right? Or 90 degrees all the way down. And then it comes all the way down again. And I have a couple of these reversed, and it just shows you the equivalent position of these angles, right? Both mathematically valid. And in that spirit, can we show how our square table with nails on it has a calculatable, confirmable circumference that we can also bring out? So he was going into, back to Dr. Zach's presentation here on all the problems, he was going into how Eratosthenes did this, and he brought up this exact circle, right? So you divide it into a circle, like I said, divide it into 24 parts, and then you know that this is 15 degrees because you have a circle that is 360. You could do it with any amount. You could divide it by 400, right? But the whole principle here is that you're using it because you know this distance. And again, using an arc length formula, the distance is the same, but the angle, the distance changes, but the angle is the same all the way through, no matter the size of the circle. That's just a geometric principle, right? And so his explanation again is, look, we're on Syene, we're on Alexandria, we make our sun angle observation, we have this differential of 7.2 degrees. By the way, they only get that by subtracting it from 90 in the original, right? Because they're assuming, again, crucially, that all light, of course, is parallel. So therefore, they can subtract what they see from 90 to get their, quote, true angle, which is what I think Zach calls the angle of deception when we get to it, which I don't disagree with as a nomenclature. So when we're looking at this, you can see, again, the representation of how you can, quote, just assume the Earth is a circle, and then we're going to use an arc length, a segment of that circle, once we divide it, which we can separate with a known distance, right? So he's, again, using the relationship between the amount of distance traveled on the outer section of the circle, also called an arc length, right? To how much difference it is off 90 of his sun angle observation of 7.2 degrees. That's how he gets 360 divided by 7.2 times the known distance between the two. And again, I can't stress this enough. The only thing that makes this calculation meaningful is this known distance. This is the only thing that ties it to reality to give it any sort of meaning, and how he comes out with this 25,000 mile circumference. Not too much higher than our 24,901 mile calculated today, right? And this is how they say that he got it. The problem, guys, is that this only has meaning if you know this distance. So then the integral question becomes, how on earth did you know this distance for sure? How do you know the distance between Syene and Alexandria so well to be able to calculate the entire circumference of Earth? Well, we'll get into that a little bit later. Again, here's a better representation, I think, that I took from one of his videos, showing that, you know, this degree of separation would only equate to this arc length by knowing the radius of this circle. That's how you get this calculation over here. There are other ways to do it, but also with other known variables. You'd have to know, like, the time, you have to know the known distance in other ways. Like I was going through it to try and figure out if you could do it. And I mean, you could do arc and chord relationships and do a sum series of chord lengths instead of this arc to approximate it, but it also require you knowing the distance. So I'm not actually aware of another way to get that distance without knowing the radius. But when we move on, he was saying that you can use this principle to plot out a map to get known distances, right? So we can use the sun, distance between 90 degrees and 75 degrees. And again, we know that's 15 degrees difference. So then we know from our diagram that the distance between these two is 1,000 miles, right? So here we are. Well, I think this is kilometers, actually. But when we go over here, right, he's got this whole diagram spread out based on this principle over here, and then observation of the sun. And you can then tell the distance based on the separation of angles, right? And he goes through a couple skits going to how you would tell the distance. And then the actual argument becomes you could then use a subsequent series of angles of equal altitude to various celestial phenomenon to build the, quote, flat Earth map, right? Now, this was from 2019, so quite some years ago, well before. And I think this is a great idea, but then, of course, that just brings us back to creating a ground map that would match the sky to get circles of equal altitude to work. And if the sky is observed in a hemisphere, and we treat it, with spherical coordinates with a negative plane value, or if we just use it as a hemispherical projection, or translate it to your favorite Cartesian version of cylindrical, spherical, what have you, rectangular. The point is, it would have to match its original projection, and the only way to match the hemispherical sky would be to create a spherical model of Earth, right? As Ptolemy put it, the two sphere model, the terrestrial and the celestial spheres. That's how you would have to do that. And I think that's how we got into our position today, our predicament with the spherical map that we have, is you have to match the hemispherical sky. Either you can match it based on concurrent sun angles, where the hemispherical view in a flat plane, or concurrent angles of Polaris, because as we went through over here, these angles actually apply both to Polaris and to the sun, right? This is how they say that Polaris doesn't work on a flat Earth. The same way they say, right? They say that, oh, you can't have differing angles, differing heights for an object in the sky. And it's like, well, that's super silly. First of all, if there was a plane over here, this was just a plane flying, and my friend was, 100 miles away from me, and we both did some trig on this plane height, and we used the sine function to get the height. My height would be different than his height, and neither one of us would have the true height of that plane. Right, so the same principle would apply. If you're going to use optics to calculate height on positions, they're obviously not going to agree. You're going to get different heights depending on your perspective-induced declination of that object. But we can factor all that in later. We're going to go through a nice demonstration. So any questions on that, actually, before I power through?
Yeah, I know. I remember back in the day, this was a big one. Like, we tried triangulating the sun. Lots of people did, and nobody could. And that's why, we came to the conclusion, okay, it's not a physical object like a plane. Like you said, we could figure that out, if you had the right, you're not basing it off of a sphere, but you're just basing it off, that's what I see. These are the angles. You get 3 people, everybody's looking at it, boom. You could pretty much tell where that plane was at that time. We can't do that with the sun. It's different. It's something totally different.
Yep. Yeah, that's the argument. I think Dr. Zach makes the argument that, well, you can triangulate a lamp, right? A point source lamp in a room. And immediately I was like, you can, but you can't do that to the sun. The sun is not like a lamp. So my conclusion is there is nothing like the sun, right? That's really what it comes down to. So to try to model it becomes infinitely problematic. I think, I forget who it was. They did the video of magnetic flat Earth where they tried to model the sun. They took an azimuth for every latitude one day for a year. They put it through a supercomputer. They did super light tracing to get all the tendrils of light to spread it out. And it came out like a toroidal flower that appeared to be everywhere at once for all observers. And it was like, oh, is that what it is? Is that what the sun is? Literally, it looked like it was riding through a toroidal hemisphere. I don't know if you guys saw that.
The manifestation of a toroid above us in our celestial arc. No, that's why it's extremely important to understand the limits of vision in Earth curvature, because that's where they put everything, right at the limit of where you're going to see it. When Shane was talking about negative coordinates earlier, that would be the difference between something going under, being obstructed by ball curvature or optical curvature, where it's setting into the horizon, you can't differentiate it, you can't make it out anymore, and that's going to be the same effect. So your limit of vision is going to set that. So all these coordinates and how everything is mapped is going to be in relation to how you perceive it. And using the sine function to get distances to the from the stars has been a practice since that's the only thing that's ever been proposed. So if we were to make our own map, what Shane just said, we'd end up making a graticule, which would be represented by a spherical coordinate system, which we could then project invariantly under all different types of projections. But you use different corrections to make them all show the same thing equally. As long as you use the thing right, then we would just, as we're educating people about the flat Earth map, it would just be telling people that, hey, the ground's not the thing that's curved. It's just how we had to map it based on how we perceive it. And then it's the, so what we're doing, that's already what's happening now. We're just correcting the issue because all the maps are the same. There's not like a special map. The AE map's not like different than the other maps. They all use the same lat long system, and the lat long system is just is a snapshot of the sky on the equinox showing you where the positions of the stars are at. So you can replace all the land features in those maps and just think of positions of the stars on the specific time of night. That's all a map is. So when you're like, where's your map? Where's your snapshot of the positions of the sky based on a specific time of year? Cool. Like that's what you want to know. Okay, great. All right, please continue, sir.
Yeah, I switched to a different presentation real quick. This is from the Switcheroo Celestial Sphere presentation because I wanted to show the difference. They're like, oh, you can't use spherical coordinates, or it's a sphere. And it's like, look, guys, if this is what we observe, right? If we live on this and the stars are doing this above us, which is true, which is what they do, then we can represent it this way, the same way you can, because it's based on a circumference, right? We have a circumference of what these celestial bodies are doing, which obviously is the same, which is how you have predictability when it, quote, sets, right? Goes beneath your feet, comes back around, comes the same distance, it's the same circumference. The only difference between these two is the negative value of this fundamental plane. So once it goes below this Z coordinate becomes negative. And otherwise, you can express everything exactly equal. That's the beauty of math, right?
Let's talk a little bit about spherical coordinates.
I don't want to play that video, but yeah, that's how that works. Let me go back to the other presentation real quick.
And in the globe, the sun has to be, 2 degrees, something like that, below the horizon when you start seeing it? You're not actually seeing the sun. That's just it curving around the Earth and rising it up above. I watched a lot of sunrises when I was doing my sun, observations on the sun. I always got a picture as soon as it got to 5 degrees. I'd take a picture of it and get the sunspots, and then one around noon and one at sunset. And I did that for like 8 months. And yeah, you go into the U.S. Naval Observatory website, it even explains it. The sun is 2 degrees below the horizon when you're seeing it above the horizon.
Oh, because it's already set, right? Because of refraction. So yeah, of course.
Yeah, it's gone. It's not really there.
The classic. So
But
real
there
quick
it is.
before you continue, I wanted to also note on, you said setting an arbitrary height to do the sine function to get the distance. The arbitrary height is extremely important because, like we were talking about earlier, when you Eratosthenes triangulate, well, you end up with 93 million miles and all this crazy stuff, right? And that's the game they want you to play. But the graticule, right, the snapshot of the sky that everyone uses to navigate is based off of setting everything to 6210. So 6,210 miles away, or 614, depending on how you calculate it out, from what is it, nautical or statute miles. But anyway, the important part though is that height is just as good as any height and it's the best height if you want to use the graticule. So if someone asks you, how high the celestial body is, my preferred answer is 6210, because that's what celestial navigation is on the backbone of. When they talk about doing the different types of triangulation where they can get the 93 million miles out of it using Venus, assuming the same size and perspective equation and all that, that's all, that's a nice role play. But when it matters, when you want to go somewhere on Earth and you need to figure out a distance and you need to sign a star, guess what you're going to do? 6210. So,
Well,
yeah, go ahead.
that's the max distance that it can be, right? That's right up here. That's the absolute height of the sun. Not everyone sees it at that all the time. People see it at all different varying lengths, but 6210 is the maximum distance, right?
Yeah, that's going to set your equidistant web for everything, and then you're going to move underneath it essentially.
Yeah, so the sun gets seen at all sorts of angles between them, including and up to 6210. The stars are always treated as an equidistant web of 6210, right? Because they're always rotating at the same distance, never coming and going. They're just rotating in the sphere. The sun is doing this whole thing where it rises to the very tip of your vision and then sets completely into the horizon.
Yeah, important distinction.
Yep. But
that applies to the moon as well, right?
Yeah, the sun and the moon do their own kind of unique thing, but they both do that action completely and get treated up to that maximum. Yeah.
And then everything else, the stars and galaxies or whatever, and the wandering stars, all 6210.
Yeah, Stephen Alonso used that determination in his cylindrical transformation via the coordinates of his Lorentz. I think he called it an adjustment that he won the TFE experiment with by trying to predict the sun azimuth and distance between longitude lines, just in case anyone didn't know. So I think so when he's addressing this, he says, these parallel rays, which was based on this, never existed, never happened. This is what everyone sees, so this is what we should be using. And of course, this is where it comes from, right? We have an angular diameter of the sun, the apparent optical disk, 0.53 degrees, and we have this covariant scaling factor of varying diameters and distances with which we can make this all one observation make sense. Right? So this is a very important part of it. It's the scaling invariance part. We know it appears to be this size. Therefore, using math, we can make it appear at all of these different distances with all of these different diameters as long as it maintains the first optical function. So all through science, right? They were like, oh, we've always been guessing at the distance to the sun. We knew Copernicus had it at 3 million, Tycho Brahe at 13, Kepler also at 13, Newton at 28 million, then at 54 million, and Martin at 81 million, Encke at 95 million, Meyer at 104 million again, and then to 92 million or 93, and they're definitely right? They definitely had it. And it's like, well, no. If you're going to contrive a story of historicity like that, all you would need is this one formula and the one observation of the sun actually and the moon being 0.53 degrees because they're absolutely identical. And then you could construct this fairy tale just changing these two variables and manipulating them with algebra so that you get these succession of sequential differentiating like distances and diameters that always tie back to the angular separation of 0.53 degrees. And that's one of the coolest tricks I think that they've ever pulled, right? Because it works. Of course, it works for a sun that's 33 miles wide and say 3,500 miles away as we pseudo calculated before. And of course, then it would also work for a sun that's 864 million miles wide and 93 million miles away, right? Same observation works because of that covariant scaling. And in fact, this is how they built the whole solar system, because this one observation is how they ultimately calculate the AU, the astronomical unit, the distance between the Earth and the sun. And they cannot calculate that without the radius, which they can only get from Eratosthenes sun angles, which we're going over right now. So that's why all that's important and relevant, is they can only get all these measurements to make everything work with this known circumference. So when you use the heliocentric model, they sort of fix everything, right? They push this to near infinity so that these angles from the Earth appear parallel, but ultimately converge at a point, therefore are not parallel. So they can, treat them as parallel, but they're not parallel. It's the most ridiculous system ever, so that these ultimately angles work and everything on Earth from the observer makes total sense. So obviously, this is how they want us to interpret the story that, as we'll get to it get at towards the end has actual no historical backing. This is how they'd want us to interpret these measurements. This is the only way you can apply a circle. Well, not really, right? If you have a circle of vision and you live in the middle of this Earth over here, and you have a plane, not only can you apply this circumference living in the middle of this plane as 24,901, if this is in fact the equatorial circumference, then you could say equally that an arc length along this circle is equal distance to that 1,000 kilometers if the sun would pass above us over here. So we can have the same observation, make the same measurements, and come to a slightly different conclusion based on our interpretation of the results. To sort of picture that out over here, if you had an object, if you saw in a radius of 3959 and you stood in the middle, and then you'd have the Earth sort of arrayed around you, you'd have the sun arc and set, and if it did circles around you, you could make measurements of the same and get the same conclusion. So therefore, we would say that these two positions are equal. If we have the same circumference, let's call it the circle of the sun versus the circle of the Earth that you're saying this is, and you're determining it by sun angles, then we can say that we have an equivalent position. So we're going to go into how we can replicate this on a flat Earth with the same measurements to get a different conclusion, right? So everyone knows that this scenario is fixed by using a local sun and all the non-diverging light rays, and that makes the same observations equally apparent. Right? Everyone's seen this meme, and they say Eratosthenes proves the Earth's a sphere. Everyone says, well, not necessarily. If 2 points, it works either way. Then they say, if you add more than 1 point, more than 2 points, it definitely only works for a sphere. And we're definitely going to prove right now that that also is incorrect. So here's another video I stole from Dr. Zach.
When Neil said that, it's like, what do you mean you add one more well and then it becomes a sphere? It's still a shadow and a light source. No.
Well, that's the other thing. The well happened to be right at the tropic, and they happen to take it at the solstice, which is like the only place on Earth the sun will appear directly overhead. And they were like, what do you know? It's right at my zenith. Like, who would have thunk it would have been right there? If they played this game. Well, now we have to tilt the whole world because we know that light's parallel and that it was right over there. So that's how they literally invented the ecliptic at the same time. But yeah, the common answer is to say that this is equally valid as this. So this doesn't prove anything. And like I said, our buddy Dr. Zach proved this unequivocally with a nice, I think, AutoCAD drawing and some 3D rendering and some awesome examples. His main argument, however, to solve it, instead of putting an azimuthal grid around the observer, he just said, look, if the sun is a point source and is refracted and everyone sees an apparent point position of it, then he solves it the exact same way. He puts a board over here. Instead of having the light source up here and everyone triangulating it to it, he just puts it over here with a lens, a concave lens, which refracts the light. And therefore, everyone measuring the sun angles can actually converge towards this one spot. And I thought that was a really neat way to solve the problem as well. Here's a specific diagram of how he outlaid it, right? He did some measurements. He put a 2-scale model, put some nails in a table, and took some precise, accurate measurements down to the centimeter of the nails. And he's going to put a point source light over the top, and we're going to measure the angles of the shadows. Right? He's going to use some tools just to measure the length of the shadow, just like this. So we're going to watch a little bit of it right now, unless you guys have questions real quick. This is a good one, though.
No, this is an awesome presentation, man. I
Very
love
good.
all the visuals and everything. It helps so much.
Nice. Yeah, thank you, sir. Even though I do have to thank Dr. Zach because I stole a lot of it from him. Other people doing great work, man. This one is great. So he did this whole model. Let me see. Get rid of this. What happened here? Double click. Double click play. There we go. We're gonna watch a little bit of it from right here.
Or light rays will intersect.
You guys seen a coordinate system slide?
No, you have the proper slide up for the YouTube video you're trying to play. You're solid.
All right. It looked really weird. All right.
Nope, you're good.
All right.
Of course not. So he's gonna do some triangulation centimeters. We could have used
right, there we go.
Sine in his experiments was 90 degrees below the sun. So that nail in our experiments is also 90 degrees below the bulb. Now the distance between Sine and Alexandria was 800 kilometers or 500 miles. But in our experiments, we can just assume it's 15 centimeters. We could have used 80 centimeters to scale it down, but we didn't have a bigger lens to cover that much distance. But it doesn't matter because the math of Eratosthenes.
Oh, making it full screen ruined it. Okay. All right, that's cool. Live and learn.
In the center of the bulb, exactly like in the first experiment. He has sound, but we didn't have a bigger lens to cover that much distance. But it doesn't matter because the math of Eratosthenes works with all distances on the globe, and I'm gonna prove that to you too. Well, the shadow of this nail that represents Alexandria is 2.69 centimeters.
No, it's not playing.
To get the angle of deception,
No, the
that
audio's going,
Eratosthenes
but the
used in
video is
his
not
experiments,
playing.
all we
You're gonna
have
have
to
to pause
do
it.
is draw the nail that is 5
Or
centimeters
now it's playing,
and draw
but
the
it's really
shadow
small.
that is 2.69 centimeters.
Yeah. All right. Side note. I'm just gonna play the YouTube video.
Yep.
Fool me once, fool me 3 times, or whatever.
Won't get fooled again.
Yeah, the George Bush adaptation.
That was probably one of the best combos
Fool me
before
once.
Biden.
I
Shame
don't
on
know how it
you.
goes. Yeah.
Fool me, won't get fooled again. Oh
All right.
man.
So am I sharing this into Discord, YouTube? No, I'm not.
There's no audio on it though.
Well, there should be once I change.
I
How
prove
about
that
now?
to you too.
Yep, solid.
All right, cool.
Well, the shadow of this nail that represents Alexandria is 2.69 centimeters. So, to get the angle of deception that Eratosthenes used in his experiments, all we have to do is draw the nail that is 5 centimeters and draw the shadow that is 2.69 centimeters. And then we measure this angle, and it is 28.26 degrees. So Eratosthenes divided 360 by his angle of deception, which was 7.2 degrees. But in our case, it's 28.26 degrees. So we get 12.73 centimeters and many decimals. Then Eratosthenes multiplied the results by the distance. If we want to do the same thing, then we should multiply 12.73 by 15 centimeters. So we get 100.
What I should say, this is a long video. It's 34 minutes. Everyone should definitely watch it. I sent the link to Alan. I'll put it in the chat. You should go check out his whole setup. He goes through how he measured it, how he set it up. I just cut right to the end where he started doing the circumference of the table, so we can all see it for effect. But everyone should definitely go check out this full video by Dr. Zach.
191.08 centimeters in circumference. And that means that 191.08 centimeters is the circumference of the globe table. Now we can assume that the table is a globe because the angles work on it, right? So the table is now a globe with a circumference of 191.08 centimeters, which makes its radius to be 30.4113 centimeters. Okay, that's fantastic, but hey, get back here, we didn't finish yet. We are way better than Eratosthenes. We're gonna prove that the table is a globe by doing too many measurements and not just one. First, I'm going to measure the elevation angle of each nail. Here we go. This is the closest nail to the central nail, which is 5 centimeters away from it. Its angle of deception is 9.42 degrees, and its angle of elevation is 80.58 degrees. Same thing for the other nail in the opposite side. They got the same shadows. Now, if we want to do Eratosthenes' formula, then we will do this. 360 degrees divided by 9.42 degrees, we will get 38.21 and many decimals. 38.21 times the distance, which is 5 centimeters, we will also get 191.08 centimeters. The result is like the first circumference we got from a distance of 15 centimeters, if you remember.
Confirming the circumference of our flat square table.
Now we will do the same thing with the last distance, which is 10 centimeters, and we should get the same circumference. Let's take a look at its angle of deception. 18.84 degrees.
Is that minus 90,
so again,
right?
360 degrees divided by the angle of elevation, that is 18.84 degrees, we get 19.1 and many decimals. 19.1 times 10, we get 191.08 again. And the angle of elevation of this one is 71.16 degrees. Let's test these angles on a ball like we did on the globe model. Let's see if these angles really work. So I'm gonna draw our globe.
This part's really cool. He pretty much just recreates all the measurements and he puts the nails on this theoretical sphere in AutoCAD, and he takes the same measurements that he made in reality to thus conclude, look, it must be a sphere. So I think he did a really good job for not only modeling it, but showing that, you know, the wonderful example of it works on a flat Earth just fine. You can calculate the circumference of this table. I thought was hilarious. However, from now on, right, I'm going to go into the weeds with the Globers, and I'm just going to assume what they say is true, and I'm going to attack their argument from a different side. But I did want to show that, you know, it's equivalent. We can do it for flat Earth if you use real measurements and you stop assuming everything's parallel or whatever. You can make the same observations and you can conclude, you know, the circumference of this flat table doesn't prove that the Earth's a sphere in any way, shape, or form, right? So excellent video, excellent demonstration by Dr. Zach. And I think I have another video, but it's not by Dr. Zach. Present, share. Big screen.
Yeah, Dr. Zach did a lot of great work back in the day. If you
I
guys
never heard of him
haven't
until like
seen,
last Monday. Yeah.
yeah, go check out his channel. It's pretty amazing, all the stuff. And he didn't make a whole lot of videos, but the ones he did were all really good quality, a lot of information. You know, he got his point across.
Yeah, I had no idea, man. Like I'm relatively new to all this, being me and Alan, right? Last couple of years, maybe. So people are like, "Oh, it's an OG like Dr. Zach," and I'm like, who? What?
Have you guys
So-
heard of Rob Durham?
No.
Yeah, he did
Well,
some awesome gyroscope work. I found his channel. The dude's
Yeah.
awesome. If I showed you
Yeah,
his
if you
channel,
wanna-
Shane, you'd recognize him.
We probably dabbled in the gyro lads though.
Yeah, we have. It's a good channel, good resource. There's another
Nice.
gyro lad too. I forget his name, but he did an extensive amount of gyroscope work for flat earthers.
I know John Savage did.
Yeah,
early
that's
on,
it.
too.
That's the one.
Yep.
John Savage.
There you go. All right. So again, this to sum up Eratosthenes so far is everything in gray is an assumption, and the only thing that was measured were these two red things. So that's something to take in mind. I thought this was a good
So wait,
representation.
they found the whole globe and those two red circles there.
Yeah, this is the only
That's
thing
so
actually
cool.
being measured. Yep.
That's so cool.
So everything else is assumption and deduction, right? So they're assuming and then calculating.
So if you live in between the tropics on a specific day, you can find the sun. You can find
You
the
can
radius
find the
of Earth
globe too, yeah.
Dude, that's so cool.
All right. So then remember I said that the distance between these two is what sets it to the only thing that actually ties it to reality, right? Is that this is a known distance between Cyne and Alexandria, whether it's 500 miles, 400 stadia, or 800 kilometers, whatever you want to call it, whatever ratio of the coordinate system in which it's referencing you want to use to measure this, you got to have this beforehand. If you don't have it, then the only thing you're calculating are theoretical circles and circumferences to be applied as you want. So this other video is it's a math lad, a famous mathematician being interviewed on the historicity of astronomical distances. So things like the AU, parallax angle is to get distance to Venus, the assumption from distance to the sun, etc. And he goes into Eratosthenes, and I should be able to start it from.
Einstein once wrote a introduction to book.
Nope, that's not it. I think 7 minutes, maybe. Let me see. How do we know? At 5 minutes. Here we go. I remember.
Which must be experiencing this phenomenon where the sun is directly overhead.
Maybe not. Oh boy. Okay, 3 minutes.
By these
4
kinds of
minutes.
compositions is how
There
you
we go,
can
we got
just
it.
see the relative size of the Earth and the Moon. We'll get to that in a moment, but first things first, how do we figure out how big the Earth is?
The first person to do this that we know of is Eratosthenes. The way the story goes is that he had read somewhere of this well in this town called Syene, where on one day of the year, the summer solstice, you could look down the well and you could see the sun reflected in the water underneath. And he said, oh, that's kind of cool. I don't live there, but I have a well in my own town, Alexandria. I'm going to go try the same thing. So he waited until the summer solstice. At noon, he went down and looked at the well, and there was no reflection of the sun. So I think, like, if you're a regular person at this point would say, oh, that story is fake news or whatever the film was at the time. Sure. And he knew from Aristotle and the others that the Earth was round. The reason what was happening was that the sun was not actually vertical.
Let's think of the sun as far enough away from Earth that all of its rays of light are effectively parallel. At any given moment, if you draw a line from the center of the Earth straight to the sun, it passes through some point on the surface, which must be experiencing this phenomenon, where the sun is directly overhead. But if you were someone in Eratosthenes' time, it would be very difficult to know exactly where this was happening at a given moment. So what makes the summer solstice special is that on that day, the axis of Earth's rotation is tilted directly towards the sun. And as a result, on this day, as the Earth revolves around that axis over 24 hours, there's a consistent line of latitude where all of the locations on this line predictably experience this phenomenon, where at high noon, it's the highest of all high noons, where the sun is overhead. This line has a special name, it's called the Tropic of Cancer, and the town Syene that Eratosthenes had read about sits on this line.
Just happens to still be there.
Eratosthenes himself was a bit further north than that, in Alexandria. So on that day, at exactly noon, the direction he perceives as straight up, which I'll draw with a pink line here, is not pointed towards the sun. It sits at some angle with all of those rays.
He had what's called a gnomon, which is kind of like an ancient protractor or sundial, a portable sundial, basically. He measured that the sun was actually about 7 degrees off of the vertical.
Critically, because he could also know that at this exact moment, down in Syene, many, many, many miles away, the sun was directly overhead, he deduced that this means the arc length along Earth between Alexandria and Syene is about 7 degrees. This in turn.
Now remember, this is the whole point, right? This is the only thing that makes this relevant, valid. This is the only datum tying it to reality. It's the only geographical point of reference that has this ratio metric mean anything at all. And we're going to figure out, well, how do they already know that? That is the next question.
Turn means the ratio between 7 degrees and the full 360 degrees of a circle must be the same as the ratio of the distance between those two towns and the full circumference of the Earth. Now keep in mind, in the records that we have, it's not like he's reporting this distance in miles or kilometers. The units they were using back then were stadia, where a single unit is something like the length of a stadium.
So the distance was about 5,000 stadia, which is about 500 miles.
How accurate is our conversion between stadia and miles?
That's a good question. We are not completely certain. So with the conventionally accepted conversions, I think the accuracy of Eratosthenes' estimate is about 10%.
You can find sources online that claim his estimate was more accurate than this, but just keep in mind if you selectively choose which of the many possible conversions between stadia and
10%?
miles to use, You can kind of
Depends on your Stadia conversion chosen elementary
10%
unit.
is pretty good with
Yeah.
no technology. But of course, all of this hinges on actually knowing the distance between
All
these
of
two
this
towns.
hinges on this.
So the natural question you might ask is, how would he know that?
This is not recorded. There are some theories.
Nobody
One
knows,
is that
guys.
there are merchants that
He
report
just
it
did.
now, and they know that in a certain day that their sailboat can travel so and so many stadia, and it takes him so and so many days, X to Y.
The answer is everyone just speculates. Nobody knows.
Some
Dude.
estimate. The joke
Yeah, but
is
it's
that he
not
basically
a
hired
crow's
for
fly. You can't even walk in a crow's fly to know how far it is. That's just ridiculous.
500 mile span. What 500 mile span near you do you know offhand that happens to be exactly that distance? Like,
Yeah,
what
none.
metric did you
Zero.
apply? Did you walk your feet 1 foot in front of the other 500 miles to confirm? Like, yeah, I know for sure that stretch is 500. Like, that's crazy. And like the whole point of this, right, is that he makes a joke about it. He says, well, in the science community, we know that he hired a grad student to go pace it. That's what we would have done, right? Like, yeah, I'm not gonna go measure that shit. We'll just have a grad student go do it. And that is literally the scientific consensus of how Eratosthenes knew that distance today, right? They make a big joke about it. But as I just pointed out, that is literally the only thing holding this whole story together. The only thing that makes any sense is to, well, all right, so you had to go measure that, right? Like, I'll accept all the rest of the story, but show me how you measured that distance so I can confirm that this is legit, right? And wouldn't you know it, that if you were to look into it, we know about geodetic surveying, right? And we know how we have special geodetic surveys, how they measure stuff by already knowing the dimensions. Well, wouldn't you know it, it comes out to be one of those stories. But real quick,
Dude,
we said that he invented
my
the tilt.
favorite, real quick, my favorite part of the story is that they all agree on the unit of measurement that defines a stadia, because they don't actually know, there's no actual record. But all these guys that, you know, that would have hired a grad student to do it too, they also all agree on how accurate the stadia was in estimating the distance between Alexandria and Sidon. So they have no idea about the processes, how the unit of measurement itself was derived, but god dang it, they know that it was accurately measured. So they knew the distance and they knew the earth was round. Two important factors to know. So
Yep.
so in establishing that, so if you're going to have a distance derived for this and you know the earth's a globe, you're going to need, what's that thing called, a graticule? You're going to need your own geodetic coordinate system to define everything based off of positions of the stars before you're even telling a story about how you led up to coming up with the system to define the positions of the stars by already presupposing it. So an important part of this argument now is that the story that we're all familiar with is like, yeah, it works equally on a flat earth. Guys, it doesn't work on a globe unless you already pre-assume the exact dimensions of the globe to self-reify it. It doesn't work on a globe. It's just a measurement that's been retold as globe evidence by hiding, by like you know how when your mom's like, hey, make sure you sweep up the living room before I come back, and you're like, oh, no worries, mom, you just pull the rug over the area you don't want to sweep. Classic maneuver, right? All they did was sweep under the assumption of Earth's dimensions before they told you how they accidentally derived it by looking at a well and a reflection of the sun. Shane, this time they didn't look up at the sun. They looked down at a reflection of the sun. So it's different.
Preposterous as it sounds, dude, it's repeatable all the time. You and I can go outside, put a stick in the sand, look at the sun angle, know what time of year it is. Based on that angle, take a differential from 90, multiply it by a known distance, divide it by 360, and boom, we'll calculate the same circumference to a certain margin of degree, right? It's repeatable. McToon did this. It's on McToon's website, right? His so-called method of measuring the radius, which nobody's ever measured a radius. They've measured the sun angles. They've calculated the radius based on the circumference, right? This is the one and only method of measuring Earth's circumference and radius that exists in the world. Anyway, the other important part is that a parallel light assumption coincidentally resulted in Eratosthenes being credited for the tilt of the Earth, right? Like, oh, we've quantified axial tilt 23.5 degrees because, again, this example city sun happened to be right on the tropic, happened to be right at the solstice. Lo and behold, just what you need to predict the globe. Perfect perpendicularity arose. He took advantage of it, and boom, we've invented this axial tilt. So now we know the sun's declination travels from back and forth. So we know the whole world must be tilted about that much for all that to make sense. All right, so here he is in the corner inventing the axial tilt, and with his half of a observed globe that he's got. And then so the actual method, if you look up Eratosthenes, right, and if you just Google, like, for real, how did he know the distance between Alexandria and Syene? And then the actual go is, well, by already knowing the distance between Alexandria and Syene, which was measured by professional surveyors called Bamatis, Eratosthenes was able to calculate the Earth's circumference. So hold on, now that's a new element. None of those histories that I read told me anything about that, but Wikipedia just straight up told me not only is it known, but it's done by these experts called Bamatis. Wait, wait a second. Well, what are those? Let me look into that. If you look into, all right, was Eratosthenes, measurement of distance between Alexandria and Syene known? And actually, no, there's no direct references of that, right? They don't mention no primary Greek and Latin text from the era explicitly mentioned Bamatis measuring this distance at any way, shape, or form at any point. There's the figure that they went with may have been derived from pre-existing surveys, we guess, or other known records, or some scholars probably proposed it was estimated from the caravan travel or geographical reports compiled at the Library of Alexandria. So here's the deal, right? We know Bamatis existed. They were dudes that measured stuff. So therefore, they must have been the ones that measured Eratosthenes. No, that's called speculation, right? So all evidence area of this is actually speculative. There's no evidence of Eratosthenes confirming this with professional surveyors called Bamatis at this time or any other. Right? There is no surviving evidence confirming their time or role. Speaking of evidence and roles, is there any direct evidence that this whole story is even true? That Eratosthenes was a Greek who lived in a certain times? And the answer to that is a resounding and a whopping no. No, 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 no. There is no firsthand evidence. There's no citations. There's no anything. The only way that we know it's true is that other people reference the story. So,
Wasn't it
Cleomedes.
1955? A book from 1955, the first time his name pops up?
I don't know. That could be true. I'm not sure when the first time it actually popped up. I just assumed that it was ubiquitous throughout history and that they started putting the seeds in place for the fake Greek stories right about 1700s, because right above the turn of that is when everything, I think, went to shit for the globe and how they invented their own history. And before that, it looks like it's always been the globe, right? And there's no actual beginning or end. It's just always been globularity as far as the history.
Yeah, there were, scholars in that town at that same time period who wrote about all kinds of mathematicians and people like that, but they just happened to leave Eratosthenes out. The one guy who figured out how to measure the circumference of the Earth, the Michael Jordan of his time, they just don't mention him. They're just like, no big deal.
I bet they forgot Hipparchus and all the other ones. Ptolemy, I'm not sure that any of them existed. If you go through,
who was the one that invented some necessary tools that they would need to derive longitude hundreds of years later, but then they just lost them in a cave until some guy reinvented them?
Yeah, that's Hipparchus. That's what I mentioned. Yeah, that's
our boy. Shout out to our boy Hipparchus.
Yeah, longitude, spherical trig, literally all the prerequisites for sphericity that you would need, and then he just sat somewhere in a nice urn for 1,700 years until the Royal Society needed him. That's the craziest story ever. And they think we're conspiracy theorists, man. That's a crazy story. So the proof of Eratosthenes, right, is in these four main works. We got Cleomedes, who wrote On the Circular Motions of Celestial Bodies. He details his method. He literally references the story in his story of heliocentricity and globularity on his orbital motions of celestial bodies. He referenced this guy. That's the proof. Moving on, we have Strabo, who actually put together the historical record of the Geographia, which is the combination of the terrestrial and celestial spheres, who Ptolemy stole from, and later, if you look up Geographia, it's claimed to be written by Ptolemy. Oh, hold on. It's so tight because he's terrified of the green screen. He won't go near it, so it's hard to comfort him from back here.
Yeah, there was a horrible green screen incident with Shane's dog on the first green screen he bought where he knocked it over, and ever since then he's been traumatized.
So hard. He won't go near it, but I think he's cool. Right, so Strabo was the dude who actually wrote the Geographia, and Ptolemy stole that book, and he cited him, and his credited with the Geographia, which is literally the amalgamation of the terrestrial and celestial spheres. It's the first book on cosmography and cartography. It's riddled with prehistoric longitude and latitude references in stadia of all known events. I read that book. It's crazy.
And invented GPS coordinates before anyone else did.
Very it's like cool. 30 pages of long lat coordinates. It's the weirdest thing you'll ever see in ancient. That's supposedly a book written in 24 BC. Give me a break, okay? Then you got Pliny the Elder, whose natural history referenced Eratosthenes' measurement, stating that actually it was grasped through his work. So it's a colloquial metaphor that someone referenced him in. And Pliny the Elder, which is a book
Pliny.
Of oral history.
Dude, of course.
And just so you guys know, when I was in college, I minored in classic history and classics. I read a lot of these books, and what you see when you read them is their historical record is an amalgamation of oral history, which is actually combined with myths and gods and legends, right? Historically, the Trojan War, right, is a historical record told by oratory, mentioned by Herodotus and the father of history. But when you go through it, it's riddled with Herculean tales of zealotry and gods coming down and acting like humans, influencing the fight in various ways. And that's the history. There is no way to separate myth from history. So when you're looking through this, if this is the historical record, right, providing fragments, was this Planticos, Geographia, Pliny the Elder, and Cleomedes, these are not historical records. These are collections of oral records of others' historical records, so to speak, passed down via oral tradition. So in my mind, is there any proof? Absolutely not. You couldn't convince me of it. Which brings us to, all right, so if this is a fake story, are there any other ways you could measure and confirm the circumference of our spherical Earth today? Of course, I asked AI, and what we come out with as well. You can do so using the Earth's rotation and knowing distances already. Okay, that's the same thing. You can do so the same thing with the stars, knowing no distance between stars. Okay, that's the same thing, using celestial angles instead of solar shadows. Nope, that's not going to work. You can look at the same thing, but use solar noon difference, the differential in solar noon between two locations, and you can get the same ratio, kind of the same thing. Or you can use GPS or satellites. So, no, there is no other way to get the circumference of Earth besides looking directly at the sun, taking a shadow angle, assuming that all light is parallel, even though no one's ever seen it, and then assuming that the circle of Earth is exactly related to the terrestrial ratio of an arc length of that circle. That's the only way to get Earth's circumference. Now, for the rest of the presentation, I'm just going to reapply that interpretation. Suppose that you can look at the sun, put nails in a chalkboard, put some sticks in the sand, place a gnomon in a cloud, and get some shadow angles, and you can always get this circumference. What is that circumference actually? Could it be the circumference of the sun, the circle of the sun, right? When you see the sun rise and set, and you say you plot it over a Gleason's map, it has a specific radius of where you'll be able to see it. And it is, in fact, about half of the map. So if you were to put the Gleason's map up, right, and you were to put a circle of the sun, this is actually a sun rise and set from the middle of Alaska, and this is an equidistant circle. Let's say this is 3959 in each direction, and you can see when he would see the sun rise and set, and how you could put that over a Gleason's map, and how this circle of the sun could very well be mathed out based on the angles of this solar object using plane trig and sun angles. And you can say, hey, based on any known distance, you can then say, well, then I know the amount that it travels on this arc length across this circle. If I'm using this circle and I say, hey, I divide this circle into 24 degrees like I was doing before, and I know a distance over here, and I can use, say, GPS or whatever to get that distance, then I can say, hey, I've measured the circumference of the circle of the sun. Mathematically equal, I would think, and viable. And this is exactly what you can measure, right? If we move it to Alexandria and we do the same sort of principle, and again, we're going to take this circle, the same circle principle, and we're going to, instead of saying that's the sphere of Earth, and this is an arc length on its spherical surface, we're going to say it's the circle of the sun, and it's an arc length on our flat surface, right? That's why I said at the beginning, circles have circumference and there's no spherical circumference. So to say that it actually would more appropriately apply to a sphere, you got a lot of work to do. To illustrate it further, again, this is the same principle we started with. We draw a circle, we use the sun, we say how far the sun travels over 15 degrees per hour. We use that known distance, we say that that is this arc length on this circle on our flat Earth, and we use the sun. I think that's just the best way to apply it. If you were to look at it like this, if you were to put right exactly over Alexandria where he's drawn his circle, right? If you're going to measure the sun and conclude this, then this circle would look like this. Well, it wouldn't really look like this because this is a map distortion, right? We have longitudinal distortion. The greater south you go, the more distorted it gets. In fact, a smart dude called Tissot put together his indicatrix, which is the tool to visualize distortion. And in fact, in reality, all these circles are the same size, right? So from the center, they get more distorted outward. This circle represents the same area as this circle, and that is the distortion power visually of this map. So when we're trying to draw a circle on this map, it wouldn't be an equidistant circle like this. If we take into account this distortion matrix, it would actually look like this, which is the exact solar pattern of light distribution on flat Earth based on Alexandria taking this distribution. So, I mean, if you don't believe me, we got this, which is playing with G projector, showing you that how, on a globe, it's actually equal. It would look a lot like that on a globe. It would look like this on this map. It would look like, let's see, where else did it go?
You know what's scary? There's a lot of people that you could show that image to. You leave the lines, take them off, whatever. Even outline the countries, and they wouldn't know what that was just by looking at that all together like that. Now, if you showed them their country first and then blew it out, they know what it was. But you just show that image. Like, I built this image in a Fortnite game, and none of the young people that played it had any clue that they were playing on the Earth. No clue. Yeah,
That's
it was
amazing.
scary.
That's pretty funny. But like that, so this circle, right? If you're thinking about a conceptual circle, if you splayed it out and you elongated it correctly for this distortion, it would look exactly like the sun circle would on winter solstice right over here. So this is the time that the measurement was taken, right, during the solstice. Here's what the sunlight would look like. Here's what the circle would look like splayed over the Gleason's map. So my position isn't to refute the circumference value or the, quote, radius calculation based on this observation. It's to reapply it, right? I choose to selectively reinterpret your measurement. Sure, the measurement's real, but what does it mean, right? And if you can take a circumference quote measurement from inside this sphere, but it matches, my hemispherical view of the same coordinates, how would you ever tell the difference from within these, which one of these you live on? Right? And the answer, I think, is you wouldn't. And that's how we got tricked into believing that this is the superest ultimate proof of sphericity that there's ever been, right? Which is crazy. And again, just as a simple reinterpretation of the same sun angles. On a flat plane with a hemispherical view, knowing this distance or whatever between these two, we can just apply it as if the circle was orthographically represented over here, exactly like this. Right? We take this circle, and we'll splay it out over here. We'll take our sun angles. Let's say this makes a concentric circle over the equatorial diameter, which is exactly what this is representing. And then we can say we can take this arc length of how long it's traveling along this circle, and we can make the same deduction of a circumference of the circle of the sun of the same dimensions as Eratosthenes so proclaimed, right? We can just say, hey, look, we've measured the circle of the sun. You just claimed it was, for some reason, the circumference of a spherical Earth that nobody's ever measured or seen. Now, to sort of wrap it up and get into what damage they did with this stuff, right? I already said how they is credited with creating the tilt, right? Because of this wonderful observation. Now we've empirically validity added value to this measurement of the tropics. Now we know the Earth is tilted, the sun's ecliptic is perpendicular by 23.4 degrees. That explains seasonal cycles. Remember with their parallel light rays, now they're off to the races, explaining how parallel light rays for an annual basis work differently based on heat distribution than they do on a daily basis when the sun rises and the same angle is present over the year. Off to the races.
That's my favorite.
The wonderful physics behind that garbage.
But it's further, but the angle, and then it's closer, but the angle, but also during the day and night, the angle.
Right, definitely taking that one from Dave Weiss. He put that one in my head. Like, now that they have parallel sun rays, right, and they're saying that actually it's the cause of seasons, which in order for them to do, they have to say the light distribution is based on the parallel light rays, because even though the Earth is 3 million miles further away during winter, it's actually warmer in the northern hemisphere, and that's not because the distance to the sun, that actually has nothing to do with it. It's the angle of the sun rays. That's why it gets hotter. Then, of course, the counter argument is, why isn't the same true every day at sunrise when the same angle is present for everyone over Earth? It should be super hot in the morning and super cold in the afternoon, and then that's the way. If this was true, if that's how seasons are caused, that's how day and night should be experienced, and of course it's not. So cheers to Dave for throwing that proof out there. But that all is because of Eratosthenes, our wonderful totally real Greek who made this celestial observation, putting forth the foundation for them to make giant leaps in logic like this. Even further, if you remember a couple weeks ago, we did the constants, the foundational constants of physics. We did big G, we get the mass of the Earth, we did the gravitational constant. Wouldn't you know that only by using Eratosthenes' measurement of Earth's circumference does big G get to have a value to calculate the density of Earth, right? So very important is our fake Greek story and the absolute measurement in conjunction with our big G being derived, right? Remember, we use Kepler's third law with the mass dependence, how they can only calculate stellar objects. I know this is a lot I'm throwing in right at the end, but we went through a whole bunch of math where they can use an algebraic simplification to deduce stellar masses based upon Newton's third law being derived from Kepler's third law. And again, I know that's a lot. We go over it all the time. At some point, we're just going to expect people to know this one, but it's not today. So
there will be a quiz later at the end of the show.
We've said it many, many times, but it's at some point. For the importance here is that the circumference is necessary for this calculation to have meaning. So when they say, oh, it's just some dude measured it, it's, well, no. First of all, they didn't know the difference, the distance. They had no idea to calculate it. They pretended professional surveyors measured it. That never happened. They referenced the story to make sure it did happen. That never happened. So the only way they knew the distance was they already knew the distance. That's how they did it. And here's how they get, using this wonderful Earth. Remember, this is how they get the radius. So without Eratosthenes' wonderful story, they don't have the framework to calculate big G or apply it correctly. They don't have the framework for the astronomical unit. Nobody can know the distance from the sun to the Earth. Nobody can then know the distance of the solar system and stellar masses. The whole system breaks down after this. So Eratosthenes, guys, is the crux of the whole story. Without this radius measurement, which we falsify over and over again on Flat Earth land, right? Without that, there is no model, right? So this is why this is so fundamentally important. Eratosthenes' reinterpretation to get a spherical Earth, which then is the building block of all of physics to make all of the constants of physics actually make sense to describe the reality with which we are presented. And there you go. That's pretty much it.
In the context of the model they want to show it in, which is extremely important, because these ratios and constants, as we covered a little bit last week, once you have the ratios and constants established, you can then make measurements against those absolute values. So some of them don't even necessarily need to be physically meaningful. They just need to be there so you have something to complete the equation. You just have to have a positive value in there, right? So, and that's really what they did. And then when they go through all the math to explain how they related everything from the measurements of shadows on the ground to the dimensions of the Earth, to the gravitational potential of the Earth based off of its density, which influences the motions of the bodies of the sky, et cetera, so on and so forth. This is how they all had to get here. And this is why things like Michelson-Morley, the motions of the Earth and all these things, when we go over special relativity, this is why this is so important, because the backbone of this one little Greek lie led up to all of these subsequent events are built upon this one little trick, dude.
Crazy, man, right? Craziness.
We just need an R value, and look what we can do, boys.
That's what it is, dude. How do we get that R value? Well, we'll insert a story where we've always known the R value. How's that?
But we act like we act like we independently derived it. we just need to insert the R independently, and then we're good to go. It's like, okay, sign me up, bro.
It's just ratios of a circle, dude, with no inherent meaning or anything. It's like, oh wait, how did you know the distance? Nah, we always knew it.
Oh, it's like, excuse me, what was that? Yeah, some Baptist, Bedimist, I don't know, whatever. Jehovah's Witness guys measured it. It's like, what? What do you mean? How they do it? What they use? What units of measurement? Oh, well, the units of measurement were probably a ratio of the graticule that we use. So 99.9% of a meter. Oh, okay. Well, I'm glad that worked out for you.
Well, first they said Bamatis were professional geodetic surveyors, where they were professional measurers of knowing how things were already measured, right? 'Cause when
What,
you
what
go
is,
down to
what is a geodetic surveyor, real quick, and how is that different from a planar surveyor? Because this is extremely important
right,
in regarding positions of the stars and knowing the
right.
dimensions of things.
Planar surveying is, mostly all surveying up to 100 square miles, where they can just take and ignore the curvature of Earth. There is no curvature for planar surveys. Now, geodetic surveying is stitching planar surveys together above 100 miles, but only can do so with a spherical or ellipsoid model for comparison, right? They have to make constant corrections both to the model and to the astronomical backbone, being geographic longitude and latitude, and they can only do geodetic surveying by previously knowing the Earth's dimensions. So that's why it's important. How can they first have measured the dimensions of anything with geodetic surveying? That's an oxymoron, right? That's silly.
Wait, I'm
So they're the
starting. I'm
guys who
starting to
pretty
see a
much-
pattern. I'm starting to see a pattern here. So if you
Okay.
assume the constant or the ratio for the thing to be relative to, you're good to go, irrespective of it being the actual dimension. So once you have that R value, even if it's a little off here or there, it doesn't really matter. Once you have it, you can go to work. Is that what you're saying?
Yes. Yeah,
And they were saying
fundamentally.
that these guys, what are they called? These geodetic surveyors of the past? whatever.
Bamatis. I'm not even sure they were
Yeah.
real. Yeah.
No, but what I'm hearing is that military purposes, this and that, they were used for. Okay, so
Yep.
you need to know how long it's going to take an army to march from this place to that place. That's what they would come back and
Okay.
tell the guy.
That's what I
They
think
didn't
it
tell him a
was.
distance or anything like that. They got out there and probably walked it at a certain
Dude,
pace
they
and said, yeah, it's going to
almost-
take the army this long.
They almost certainly used Roman paces, which was the metric unit of the time, which was exactly for this purpose, right? And then they have
Yeah.
other measurements becoming a ratio of this paces. That's how they get stadia. It was a certain collection of paces. 1,000 paces equals a stadia, dude. So, like, yeah, almost certainly that's what they were doing. They weren't measuring the 500-mile distance that you were joking about before. No one's pacing out 500 miles to confirm that, right? That's a silly thing to assume has happened.
Yeah, that's ridiculous.
All right, so yeah, that's the Eratosthenes Sun Eagles presentation. Good conquering the problems of flat Earth as people present them. Also, we usually go into the model to show how that conquers the angles, because the azimuthal grid over the observer is the only answer for that sun angle, right? You got to put the spherical limit of vision over the observer, and then you can properly predict the sun's azimuth for all observers. Without that, I don't know how to do it. If anyone else has a suggestion, I'm all ears.
Hey, real quick before we continue on, if you guys want to send in super chats, all the money goes directly to Cami from the super chats, and we will answer any questions that you have in regards to whatever you ask. That was an awesome presentation, Shane. Really breaking down with specificity and a provided solution for the mechanism by which we observe everything and define the maps. It turns out that everyone just used their eyes and looked at the sun.
The sun. It's all based on the sun, man. Sun angles are the basis of the globe, and that's why they became the bane of flat Earth, right? Because they tried to claim exclusivity of the sky.
Yeah.
See that sun? That belongs to the globe. Don't touch it, Flatty.
Belongs
Get your hands off that. It's not yours. You can't have that.
I was listening to this biologist talk about the sun and how getting people to not be out in the sun is like one of their main goals. The sun doesn't just produce melatonin, it creates, like, I think he said over 100 and something different chemicals just from sunlight hitting your body, stuff that you need to keep you looking young and, all the stuff moving. The sun is so important. I mean, take a plant out of the sun and see what happens to it. We're the same thing. We need sunlight. We really do. I'm
Yeah, I
going to
think
spend
it
a lot more
comes-
time outside this year.
It comes down to frequencies, and like your sleep has to coincide with your sleep cycle. Like if you don't open your eyes, like go in the morning, and you don't get vitamin D at a certain time, it affects your, what do they call that? The what cycle is that? That with a circadian rhythm, right? It affects that the next day, because your body is meant to imbibe the sun. That's why when COVID happened or whatever, they were like, no one take vitamin D, it's bad. Even though it might cure you and help you, don't do that. Definitely don't get in the sun. Matter of fact, stay inside, close the churches, close the bars, stay 6 feet, wear a diaper on your face. That'll probably be the best bet. Or if you go in the sun to the beach, you'll probably cure yourself. Like, that's crazy. There you
Mhm.
go.
Yeah, sun is important to get.
I think I linked Dr. Zach's channel before. I definitely grabbed a lot from him. That AutoCAD demonstration of the circumference of his flat table, I thought was remarkable. I thought that was fantastic. It's like, how better to show them how ridiculous the argument is, besides to calculate the circumference of my table with such specificity too. Like,
Yeah, like
me,
such
how many spots?
specificity.
He's like, oh, do you want to use one position? I'm going to use 12. I'm going to calculate to the 12th degree the sphericity of my table. Like,
There you
are
go,
we done
Neil.
yet? Can we stop? Yeah.
Yeah. Yeah, that guy's taking a beating now. Neil deGrasse Tyson. He's showing how stupid he actually is. When you talk about things that nobody really knows or cares about, like all this space stuff, the average person, of course they don't know, but really they don't care. It doesn't affect their life in any way. But now Neo's talking about this transgenders in sports and all this stuff and trying to defend it. Like, boys should be playing sports with girls. And yeah, he's trying to defend this. It's insanity. But
going against the president, man. He made a decree or whatever I heard.
Yeah. No, I love it because people are finally seeing how dumb this guy actually can be. You know, his terms of science and how loosely you should take it when Neil says he's talking about science. Oh, I can't stand
Yeah.
that guy.
Yo, what's up, Taylor?
I had a question about the Greek writings. So I was also trying to find some Eratosthenes' original writings, which don't exist. So then I was looking at like who actually like referenced him, like with numbers, and it was just like Pliny the Elder and Cleomedes. And then I was like, okay, well, let me look at some of Pliny the Elder's original writings, and like they don't exist either. So
Oh no, they double Plimied us. Dang it!
Yeah,
Don't
the
take
only
away,
record is
don't
some
take
other
away my
dude said it.
Plimy.
then I was trying to find some of Cleomedes' original writings, and I searched for a couple hours and then just gave up. So I was having trouble getting access to them. So do you have any of those originals, or do you know where I could find them?
No, I assumed that it was all oral history shenanigans, and there's actually no record of anything.
Oh,
That's my-
Taylor, you know they all burned up in the Alexandria fire, and now there's only
There was
loose
several
references
fires,
of people that
so-
used to work there, and they'll have like a little cliff note in their diary, like, and yeah, Eratosthenes was a cool dude. He used to work here. That guy measured the earth with the sun shadows. Anyway, everything burned down, and Eratosthenes was a great guy. Peace.
definitely was real. Like, let me just verify his measurements. I measured them myself. It's definitely real. No, there's no evidence. Trust us, bro. Put it in the book. It's all done.
Yeah, I was also reading about the stadia and how like they don't really know how long that was. Like whenever I was trying to find these writings.
Very
so that's
good
really
point.
important. I'm glad you mentioned that.
That's why they
Yeah.
were like, we give it an error margin of 10%. It depends on how you translate your stadia, like where your personal stadia conversion metric lies. If you want to get closer to the known circumference or further away from it, you selectively apply your stadia. You're fine.
It depends on how much you want to agree with it. So, what was it, a couple weeks ago, you did a Prezi on sky miles, right? And that relationship and how units of measurement, either imperial or metric, are derived from the same thing, which is a fraction of the graticule itself, which is how they do everything. So for them to be like, oh, the stadia is in plus or minus 10% of the known, no, you guys just agreed on a ratio of what's already been established, and then you're trying to act like that independently verified everything that you're now building upon. What they've done is so crazy with this story, because you can't have one without first pre-assuming it, and they have to deliver it in this way where they uniquely independently verified it through different mechanisms, and it can't be done without even first assuming it. So this is understanding that relationship between units of measurement and the sky is extremely important, because that's what they're using against us to convince us of all this.
Yeah, I had to whip out the old presentation on sky miles yesterday on the Czech lads because they were trying to be like, how do you can't use Haversine. Like, you're not allowed to use Haversine. That's our stuff. You can't have it. And it was like, well, if you were to use Haversine, the components are literal geographic long lat. Like, you have an input long lat, you have an output long lat. It computes longitude, latitude, coordinates. So when I say it's a reference of the coordinate system itself, like, that's what I mean. So if you're going to use nautical miles, which are also a ratio of a circle, a ratio of a terrestrial meridian, which end up being part of the circle, right? Those are both nautical miles and Haversine are specifically tied to the coordinate system. That's why distance measured in both remains invariant under transformation, regardless of the shape of the Earth. Anyway.
Well said. Great questions, Taylor. Did you have any other ones?
No, just if anybody has those writings, like I would love to see them. Apparently, the University of California had some from Cleomedes, but I could never find them. So yeah, that's about it.
We just
And you
gotta
really
tap
have
Eric.
to watch out for, people make books today that could be passed off as an ancient book. You just get the right kind of paper and the right kind of ink and lead, and they might even say they're doing carbon dating, but it's not a biological living thing. So it's just stupid. There is no carbon dating on these books like they say there is. It's a joke.
Well, dude, speaking of fake history, I'll tell you a quick story, dude. All of our known history of longitude comes from one electric dump to one museum from the Royal Society in 2014. It was one WinRAR archive of old-looking, soaked, parchment-like documents that all show the historicity of the chronometer, the history of longitude, how Isaac Newton made a boast, how they got the longitude together, put out the proponent to go down to the south. We'll give you 500 gold pieces to measure the furthest longitude. All of that story, all of that historical record comes from one source, which was digitally released into a museum from our friends at the Royal Society in 2014. So then my question is, did any of that really happen? Follow-up question, how hard would it be to fake if the answer to A is no? No.
It would be
Yeah, that's
impossible. There's too
right.
much paperwork to fill out. You would
much
never be able to
paperwork.
do it. Never been
Like,
able to do it.
old looking vellum up yellow parchment with some old English on it, and people just writing what they want you to think is history. Put it in wiki, scan it to the museum, boom, off it goes. Historical record, guys, check it out. Courtesy of the Royal Society. Like when I first look into the history of longitude, I went, "Is all of this bullshit? I got my bullshit bar is going off really hard right now. This is bad. Is this all we know? Uh-oh."
That's not good. Yeah.
Yeah, it's so crazy to have people believe these manuscripts. It's so like biased too, because like there'll be like hundreds and thousands of manuscripts like in near the time of Christ, and they'll be like, oh, that didn't exist, right? But then there's like maybe one or two hundreds and hundreds of years after Aristotle, but they want to believe Aristotle's story, but like just be extremely biased. That's so funny.
Yeah, I've come to the conclusion that I don't believe anything before 1979 when I was born. I don't know. And even really not even then. I mean, even
Right.
stuff that's happened since then. If you don't really do a deep dive and you go and look at what the history books tell you, is that really the truth? I mean, we've seen it time and again. I mean, conspiracies, right? Groups of people coming together to lie. It happens all the time. It's happening right now, somewhere, guaranteed.
Yeah.
So yeah, I don't believe anything unless I can test it myself. Other than that, it's an idea, pretty much.
Yep.
Questioning the foundation of America right now. I don't believe in the Civil War. My current looks into it anyway.
Yeah, I don't know,
Yo.
man. I wasn't there. I don't know.
Welcome to the show, Halo. Do you have a question for Shane?
Yeah, it's kind of you guys were talking about Neil deGrasse Tyson earlier, and I was I had a question because they're out on the internet telling people, like Bill Nye is also on there too, and they're telling people to go to a lake or go to a seashore with a pair of binoculars, 15x magnification on them, and watch the ships as they disappear over the curvature of the Earth. And then you can literally take out your P1000 Nikon camera and zoom right back in on that sucker. And then I try to explain this to people that disproves what they're saying, but then they try to say that that's an optical illusion. But I try to tell them that the camera can't see optical illusions. It can only see what's exactly in front of its vision. And I was just wondering if you guys had a way of conquering this optical illusion or mirage that these people keep coming up with.
Well, there's a couple of solutions, but I'll let Shane start us off before we get to the old celestial theodolite.
Yep, that's a good way to do it. But I was gonna argue the bottom up obstruction thing as a function of optics is like easy to prove, because if you argue it's a facet of eye level, right? And the example is you put a water bottle on a street and you bring your eye level down, you'll lose the bottom of the water bottle on your flat level warehouse, road, street, whatever you're doing. And on the bottom becomes the first to lose visibility. That's a function of optics. It's a function of angle compression. If you're in the middle, the angles will compress equally. If you're anything but that, meaning at the lower, they'll compress unequally, meaning the compression will be steeper up top. You'll get a bottom up obstruction. The way to prove that though is to like use a hallway. So say if what we're saying is true, it's optics based, then you should be able to replicate it in the inverse. And you can say like, if you go to a hallway from the top down and you replicate the effect with your observer at the top, then you get top down obstruction optically as you lose the top of the hallway first in the same circumstance. And you can do the exact same effect at a tall building you can go to, and you can look at the top floor and you can walk to it closely and you can see the top compress vertically first. So you have the reciprocal effect. You have top down obstruction as a function of optics from increasing your observer level, right? Because you're way down the height. That's my favorite way to argue it, but I don't think a lot of people grasp that. You could just yell at them and say it's because you're closer to the ground than the sky. That's really what it comes down to.
I have a funny response. They should tell them. Ask them whenever we see boats floating over the water if that's what's actually happening. Ask them why that happens.
You can bring up the angular resolution limit and diffraction. It's inversely proportional to the size of the lens. So you bringing out that bigger lens means that you can now see further, or make out more along that horizon line.
Yeah, you make out more
The
of what's
little
already
diffraction
there.
line is smaller now, so you can see more of it just by making your aperture larger. That's a big. I mean, it's a fundamental limitation of physics, the physics of optics. There is no, your eye, cameras. There is no way around this to where they can say, oh, well, the math definitely says the bigger your aperture gets, the more you can see further. Like you can distinguish two different light sources from further away. Like you say you're looking at a car driving away from you and it's right up next to you, the lights look 6 feet apart. But, it gets 10 miles away, that light now becomes one light source. And your eye can't differentiate between the two. But you bring out a big super zoom camera and now you can see both light sources again. So it's the same thing on the horizon, just turned sideways. Yeah, it's just a limitation of optics. It's what it is. You bringing out that bigger lens and being able to see it again doesn't mean you're looking around a curve. That's ridiculous nonsense. Then do that.
Wait.
Do that on a hallway. Go around a hallway, a curved hallway.
Have you heard? Hear me out, boys. Have you heard the bigger boat argument?
No.
Wait, you've
Yeah,
never
my super carrot solo.
zoomed in on a bigger boat and showed that. Bigger boats go over the curve. The little boats, they don't go over the curve. I don't know. That's just something someone said to me one time with a straight face. So I just thought I'd bring that up in case anyone wanted a good chuckle. You're gonna need a bigger boat or whatever from that movie about the shark.
That's great. Yeah, that movie traumatized me. For the better, though. I'll say that. People say, oh, there's not that many shark attacks out there, right? You know how hard it is to get a shark attack identified as a shark attack? Like, say you're walking along the beach and you
Oh,
find a
really? Is it
mangled
one of
body
is it
there.
one is it one of those deals, huh?
Yeah, you find a mangled body on the side of the beach, and you call it in that was obviously eaten by a shark. That person had a heart attack out there in the water, and then the sharks ate their dead body. That is what's reported.
Wow. Dang, it's the reverse COVID, huh?
Mhm.
Respect. That's how they keep them stats down, dude. The sharks are humble animals. They're like, they'll just swim right next to you. They don't even want to eat you that bad. It's like their body count's crazy, huh? All right, that's
Yeah,
awesome.
it's a lot more than they tell you it is. So I'm
All
not
right.
that crazy for not going out there.
All right, lads and ladettes, we're coming up on 2 hours. Let's see, checking the chats here. There don't appear to be any pressing questions for the boys. Jaws. Yeah, that was the name of the movie. Thank you.
No globe hate from our haters.
Let's
Talking
see.
about this is their best proof. They usually don't like when we take stuff away
Oh,
from them.
Eratosthenes was my great great granduncle, and he definitely measured the globe. Shane's a liar. Response?
Valid. That's a valid point. That's probably how they knew the distance between Alexandria and Syene. I bet one of his ancestors wrote it on a wall, and they knew it from before.
Awesome.
Also, nobody knows how they coordinated between 500 miles. The Eratosthenes cell phone, Eratosthenes ether wind, got a ultra fast canoe. I don't really know how he would have communicated 500 miles to get those measurements.
Are you talking about the speed canoe? That was invented by a Greek long before they knew they were ever going to know that they needed it, and he left it in a cave, and then it was rediscovered about 6 months before the Bedimists put it to use.
I thought they just pieced together the ashes from the Alexander fire and said, "Yeah, we think they say this based on the ash patterns."
Yes.
Yeah, carbon dating. Yeah.
Yeah. It's kind of like when you drink your tea and then look at the leaves at the bottom of the cup or whatever, and like tell stories about the past.
And then you get a scientific hypothesis based on the tea leaves. Yeah.
All right, very cool.
I think they call that divination. I think they call that.
Yeah, it's
Right after
divination. It's
potion.
divination.
It's right next to the potions class at the college.
Everyone's going to Hogwarts.
All right, lads, I'm going to go ahead and wrap up then. Hope you guys enjoyed the
good
Prezi. We'll be back
show.
on Sunday. Taylor, what do you got coming up this week, big dog? Nothing? Okay. Zach, what do you got coming up this week, sir?
I'll be doing the usual Monday, Wednesday, Friday morning, 5 a.m. Eastern over at Iron Row Media. YouTube, Kick, I think there's a couple other platforms. And then freeworld.fm, one that actually I don't even think they're having some technical issues over there at freeworld.fm. You can still get the show, but it's a weird link, and I don't even know how to get into it and do it over there. So don't even worry about freeworld.fm right now. I'll let you guys know when that kicks back on. There's a lot of truth speakers over there. It's really kind of like TFR used to be back in the day.
Nice.
It isn't just flat Earth or this or that. There's a lot of like health. There's money, talking about the Federal Reserve and all the crazy stuff that goes on. There's just a lot of cool people over there. So yeah, you can go check it out and see who's even over there. And if there's anything you like, I know you can go back and listen to old shows and stuff like that too over there. But yeah, and then Thursday night we didn't do the Globebusters Tech. We will have one this week though. We'll get that out there this week for you.
Awesome.
Nice.
Let's see. Halo, you got anything coming up this week, sir?
No, I just kind of just work and try to help people out with finding out truth and stuff like that, because there's a lot of stuff that they hide from us, because it's about really maintaining their control structure and power over everybody. Because if people actually knew that there was stuff down in Antarctica, beyond the ice wall, and there were other resources and lands down there, people wouldn't stay here. Just like before 1492, before Christopher Columbus came over here to America, everybody who stayed over in Europe. And then when everybody found out about America, everybody came over here to America. So, and it was about escaping the tyranny of the European hierarchy. So,
yeah, got to keep the people in the dark to keep them enslaved. Absolutely. Shane, what do you got coming up this week, big dog?
I don't think anything. I think we got TikTok. I think Wednesday and Thursday. I think we got presentation Tuesday. What's going on Tuesday?
Ooh, either open roundtable or or hear me out, a quick thrown together sub 24-hour presentation on inertial forces and which
I
frames
like
they
that
apply
already.
in.
That's it. That's the one.
That's the one. Okay, I'll see what I can do. All right, so stay tuned for community open discussion night, and then next week will be the other thing that I mentioned.
There's one single video that's responsible for leading over 2,000 Christian men to permanently quitting the P word. And this video that I'm going to share with you in a second has been creating waves on social media and sparked a movement of men stepping up and breaking free from the chains of the secret life they've been living behind closed doors. So here's the deal. If you click on the link somewhere on this page, you're going to be able to watch that very same video and see the